So we went over the international system of units and its prefixes, and we also went over the rules and tips. So now we want to apply what we learned and do some examples. So for example 1, we want to go ahead and represent the following combinations of units in the correct SI form using the appropriate prefix. So for part A, I'm going to do a quick rewrite just so it's a little bit more obvious, this division. So I have megagrams over milliseconds. And then you want to take these prefixes and you want to write them as powers of 10. So mega is 10 to the 6th power, and the milli is 10 to the negative 3rd power. And then you can go ahead and simplify powers of 10. So this is going to be 10 to the 9th power. And then go ahead and rewrite 10 to the 9th power using a prefix. So I can write this as gigagrams over seconds. I'm going to do the same thing for part B here, where I'm going to take the prefixes and write them as powers of 10 first. So giga is 10 to the 9th power, and the micro is 10 to the negative 6th power. And then I'm going to go ahead and combine the powers of 10. So I just get 10 to the 3rd power. Newtons times meters. Make sure you put the dot here to separate those two quantities. And then 10 to the 3rd power is a kilo. So I have kilonewtons times meters. So you can leave it like that. If you give me newtons times kilometers, that's fine too. And then part C here, again, I'm going to rewrite this so that the division is a little bit easier for me to see. And here we have to be careful because I have a square, right? I have an exponent on one of these quantities, on the seconds. So I'm going to rewrite this. I'm going to go ahead and put the parentheses. And then I'm going to go ahead and rewrite the prefix, the kilo, as 10 to the 3rd power inside the parentheses, so that I don't forget to distribute the exponent, the square here, onto that. So I have newtons over 10 to the 6th power seconds squared. And then I want to go ahead and take the 10 to the 6th power and bring that up into the numerator. So I'm going to rewrite it as 10 to the negative 6th power. And the reason why I'm doing that is because I don't want to have a prefix in the denominator. So now I have it in the numerator, this power of 10, so I can go ahead and write it as a prefix now. So this is going to be a micro. So I have micro newtons over seconds squared. Example 2, we want to go ahead and represent the following quantities in the correct SI form using the appropriate prefix. All right, so basically I'm going to take this decimal and start moving it over to the left. So 1, 2, 3, 4, 5, 6. So I can rewrite this as 5.018. And then since I moved it 6 places to the left, this is 10 to the 6th power. And then 10 to the 6th power, I can write that as a prefix. So that is a mega. So I have 5.018 meganewtons. Part B, I'm going to do the same thing where I take the decimal place and I just start moving it. So it looks like I can move it over 3, so I'm going to do 6.73, 10 to the negative 3rd, and this is milligrams. So 6.73, 10 to the negative 3rd. This prefix I'm going to rewrite as the power of 10. So this is 10 to the negative 3rd power. Still have your grams. And this is equal to 6.73. These I can combine, so I can write that as 10 to the negative 6 grams. And then I can rewrite this one more time by taking this 10 to the negative 6 and writing that as a prefix. So that's your micro. So I've got 6.73 micrograms. And last one like this, part C. So I have 421, 10 to the 5th power. And here I have millimeters. So I'm going to go ahead and take this prefix, write that as the power of 10. So I have 10 to the -3rd power meters. Okay, then I can go ahead and combine these powers of 10, so I have 10 squared. And I can't write it as a prefix yet. I need this to be 10 to the 3rd power. Then I can write it as a kilogram. So I'm going to borrow basically a 10 from here. So I'm going to write 421 as 42.1. And then this 10 squared can become 10 cubed. So I have 42.1 kilometers. Example 3, we want to find the weight in newtons of an object having the following mass, and we're going to use the appropriate prefix. And then as a reminder, in the last section, we learned that weight is equal to the mass of the object times the acceleration due to gravity. And since we are in the international system of units, G here is equal to 9.81 meters per second squared. All right, so for part A, I have 10 kilograms. So I want to know what's the weight. So this is going to be the mass times G, so 10 kilograms times 9.81 meters per second squared. And so I'm going to take these constants here and multiply them together to get 98.1. And then I have kilograms times meters over seconds squared. And then this right here, that's the derived unit. That's the Newton. So I'll put that on the side here. Newton's equal to kilograms times meters over seconds squared. So I'm going to rewrite this one more time as 98.1 newtons. So if I have an object with mass 10 kilograms, its weight in newtons is equal to 98.1 newtons. Right, so part B, the weight is equal to m times g. So I have 0.6 grams times 9.81 meters per second squared. So I'm going to go ahead and multiply the constants. So that's going to give me 5.89. And I have grams times meters, make sure you put the dot there, divided by seconds squared. Now I can't write this as a Newton yet. Can't write it in terms of newtons because Newton is equal to kilograms times meters over seconds squared, and I don't have a kilogram, I have a gram. So I'm going to have to rewrite this so I can get a kilogram. So I'm going to write 5.89, leave a little space. So if I want the gram to become a kilogram, I need to have 10 to the 3rd power, right? So if I multiply this by 10 to the 3rd power, I'm also going to have to multiply by 10 to the negative 3rd power, so then they cancel out. So this way I haven't changed the quantity of this. Right, so I have 5.89. This I can write as a milli. This is your kilo. So I have 5.89 millinewtons. Part C, last one like this. So the weight here is equal to m times g. So in this case, it's 4.30 megagrams times 9.81 meters per second squared. Okay, so I'll do the same thing where I go ahead and multiply the constants here. So this is going to give me 42.2, and then I have milligrams times meters divided by seconds squared. I'm going to rewrite this again. So I have 42.2. Mega is 10 to the 6th power. And then I'm going to rewrite that 10 to the 6th power as 10 cubed times 10 cubed. And the reason why I'm doing this is so that I can rewrite this as a kilo and then put it with the grams so that I can have, I can convert to newtons. So this is equal to 42.2 kilo times kilograms times meters divided by seconds squared. So this right here gets replaced with a newton. So I have 42.2 kilonewtons. All right, example 4, we want to evaluate the following and express with SI units having the appropriate prefix. All right, so for part A, I'm going to rewrite this just so I see the division a little bit better. And then the first thing I want to do is rewrite the prefixes as powers of 10. So that's a micro, so that's 10 to the negative 6th power. And I have a milli, so that's 10 to the negative 3rd power. Then you can simplify the powers of 10. And then I'm going to go ahead and divide this. So I get 5.85, and this here is milli, meters, and this is over seconds. All right, so part B, I'm going to go ahead and multiply these constants together to get 210. And then I'm going to go ahead and take these prefixes and write those as powers of 10. So the milli is 10 to the negative 3rd. The giga is 10 to the 9th. And then my units here, I've got newtons times newtons. So I have to be careful because when I simplify this, I'm going to have newtons squared. And remember with the powers, if you have the quantity squared and a prefix in front of the quantity, then it's implying that the prefix is also raised to that same exponent. So I'm going to write 210. This I'm going to simplify. So this is 10 to the 6th power, and this is newtons squared. So I'm going to go ahead and take 10 to the 6th power and write that as 10 cubed squared. And then I can write this as 210 times 10 cubed newtons, and then all of that squared. And I'm going to go ahead and rewrite the 10 cubed as a prefix. So that's kilonewtons now squared. And then you can leave it like that if you want to, but you don't have to have the parentheses. So if you write it like this, that means the same thing. The kilo is still squared. All right, so I'm going to go ahead and start part C here by rewriting these prefixes. So I have 200 times 10 to the negative 3rd power meters. And over here I have decimal 7 mega here, so that's 10 to the 6th power newtons, all of that squared. I'm going to leave this part here alone for now. And then I'm going to distribute the squares through. All right, so still going to leave this part alone for now. And then over here, I'm going to start to simplify. So I have 0.49. This is 10 to the 12th power. This is 10 to the 12th power newtons squared. All right, I'm going to take the 200 and this decimal 49 and multiply those together. So that's going to give me 98. And then I'm also going to take these powers of 10 and combine those to get 10 to the 9th power. And then I have meters times newtons squared. Make sure you put the dot here so that you know it's meters times newtons squared and not milli newtons squared, right? So just be careful with that. And then this here I can rewrite as a prefix. So I have 98 gigameters times newtons squared. So that's it, that's the answer, and that's how I would do the problem. So I chose to put the prefix here on the meters and not on the newtons, and the reason why I did that was because meters is just the 1st degree, and newtons here has the exponent 2. So like the last example, if you want to have a prefix on a quantity that's raised to an exponent, then that prefix is also being raised to an exponent, so you have to be careful. So this is how I would give the answer. But if you wanted to put the prefix on the newtons, this is how you would do it. I'll put it over here. Basically, starting from this step, you can write this as 0.098 times 10 to the 12th power meters times newtons squared, and then write this as 0.098 meters times 10 to the 6th power squared times newtons squared. And one more time, this will be 0.098 meters times mega newtons squared. Mega, since we have 10 to the 6th power, and then basically that prefix is also being squared with the newtons.